Hi, yeah, I'm Alex. I'm going to talk to you about what we're working on to put Bazel in the Angular CLI. I'm the lead of Angular's tooling team, which is comprised of the Angular CLI that most of you probably use, the toolchain that we use internally at Google, and I'll talk about why that's different for building Angular apps, and I've been working a lot on converging these two things. And this is a short link that you can look at if you want more information generally about this talk. I'll put the slides link on here later today or maybe tomorrow. And it has a bunch of other pointers to other talks that we've given. So what is this ABC thing? And it stood for different things at different points in time. It's good to pick a retronym that you can use to fill in whatever. You can alter history. It used to stand for something I'm not going to mention. Right now it stands for Angular Build Tools Convergence. And so by convergence, what I mean is if you look at the way the tool chains work today, this is a simplified Venn diagram that shows the overlap between the tools we use at Google and the tools that you use today. And I realized I should make them overlap slightly because we mostly reuse the TypeScript compiler, but even there we've customized it. We have our own custom TypeScript compiler because we could. So the goal of ABC is to make these two bubbles overlap more. And it's really pushing in both directions. So today, Google is a little bit on a technology island because we've built all of our own stuff. It might be useful for the things that are available open source where they're as good as ours or they could be made to be as good as ours. We should just be using those. Things that we've developed at Google that you would like to use, we should make those open source and make them work for you. And of course, for the Angular team, since we have to support people in both of these bubbles, it's a lot of extra work for us to have to maintain the two different tool chains. So the more similarity we can make here, the better we can make the user experience for both our internal and external Angular users. So ABC is this general umbrella effort to make the tool chains and the developer, like the DevOps story, more similar. But the particular part of it we're working on right now is the build tool, because the build tool is really core to how things work at Google. And the build tool is called Bazel. We've been working on this at Google for 12 or 13 years. It was only open sourced a few years ago, but it's the same code base we use. And it has some great properties. I don't have enough time, and you don't probably have enough interest for me to talk about these at length, but these are some top-level bullet points. Incrementality means that if you make a small change in your app, you should only have a small rebuild. Pretty simple. We break the build up into lots of small pieces so that when something changes, it's like dirty checking of, it's like change detection in an Angular app. We look at which nodes need to be redone, and we only redo that work. It's deterministic, or at least most of the Bazel plugins are made to be deterministic. That means that given one set of inputs, you'll create the same outputs every time. So that's good because it means you can trust a cache. So if you have some inputs and you don't want to have to run the thing, you can just check the cache, and if the checksums of the inputs are there, you can just download the output. You can skip redoing work. The flip side of that is that the builds are hermetic. They don't depend on anything except their inputs. So this means they should have stable ordering of hash maps that they write into the output files. They shouldn't put like timestamps into the output files. They shouldn't depend on some environment variable that you set on your machine last week, and now your coworker's asking why the build doesn't work, and you can't remember what environment variable that was. Once you have this hermeticity property, it means that the steps in the build don't have to run locally on your computer. We can easily farm them out to run on a remote build execution farm. We can run steps in parallel across a lot of machines. Bazel is composable. Composable, you can think of this like Unix pipes, where you can take some program and just pipe it into some other program. And if you're a maverick on the command line, you can like assemble really cool programs just on the fly from putting a few building blocks together. It's a similar property where you can take some of the Bazel rules that we wrote and write your own and like chain them together in a novel way. So it's a really good story for how you can make your build a little bit different from everybody else's. This is something we do at Google all the time. Every build is a snowflake. Like most people use the same stuff, but there's always something a little bit different about your project and your requirements. Industrial grade, we've been using it for 12 years. Like I say, we use Bazel for basically all builds at Google, with the exception of like Chromium and the Android open source and like some areas that are different on purpose. And it's universal, meaning you can use it to build all of your different apps. But also the word universal I'm using there is intentionally sort of a pun on what we do in Angular for server-side rendering, because being able to build your server app is an important part of having a good story for being able to like build a full stack with Angular. So again, you can go back to the document I referenced earlier that has links to more talks and slides if you want to learn more about those benefits. We are using it. Angular itself has been using Bazel to build our releases since version 6, I believe. And we're still porting legacy bits of our build infrastructure into running on Bazel, but 5 minutes?
No, since 5.
Since Angular 5. Wow. Igor deleted build.sh from the Angular repository. If any of you have ever contributed to Angular, you might have run build.sh and thought to yourself, really? A project as big as Angular just has like a shell script? I thought build systems had to be complicated. Well, they are. Build.sh was more complicated than you might think. Google is using Angular built with Bazel all over the place because we only use Bazel. So anywhere that we use Angular, we're using them together. So projects like Analytics and Shopping Express and Google Cloud Console and a long list of other projects. Those are some of the bigger ones. And then there are some enterprise customers who I've been working with who are prototyping using Angular with Bazel. And I'll talk more about the roadmap for when it's time for you to use it later. So I do want to point out that we had a big speed up in the Angular build. So this is a really cool talk. I love the way this talk shows the idea of you have a big build, and there's a lot of steps to run. And so the first thing you do is you filter through this cloud cache. So anything that your CI has already built recently, hopefully your CI is running close to head, so it's already built all of your stuff. Well, most of the time, even if you're doing your clean build first thing in the morning, most of your stuff should come from that cache. But sometimes you'll make a change that actually dirties most of the cache, like you update your version of TypeScript or Angular or something. OK, so now the cache has a bunch of cache misses. But that's OK, because you can execute the cache misses in parallel on a huge cloud compute farm. And the reason that there are nice polished talks about this is that Google Cloud offers a service specifically for Bazel that does the remote execution and the remote caching. There are also repos that you can use to set it up on your own on premises if you need to. But this is one of the really cool things that we can do with Bazel that I think would be very hard to do in any other build tool. And it's because it has these hermeticity and reproducibility properties I talked about before. So this is how slow Angular's build used to be. It's in seconds, which is not a great axis, sorry. So if you can imagine sitting for 3,500 seconds versus however many seconds it takes now. I think it went from like 6 minutes to 1 minute. And we've been improving this over time. So the coarse and fine here is just that we made an internal improvement in how we track the NPM dependencies. So instead of all of the NPM dependencies having to be shipped off to those remote execution workers for every build that we do, we expressed which NPM modules are used for which steps in the build. And so now we have fewer inputs to these actions. It also means if you change one NPM package, you don't have to rebuild the entire tree. So there's a lot more optimizations like that we think we can roll in. OK, before I go to the history lesson, unfortunately, my computer rebooted just before we started, but this should be pretty quick to bring back up. So I'm going to attempt to do an extra demo here that I never planned. Wish me luck. Also, I just started using this machine last week, so I don't even know how to do anything on here. So wish me more luck. OK, let's see if this takes forever, we can give up. But OK, let's see. Who am I? Sudo su. How much can I remember about my setup instructions? ng. Don't worry, I have the instructions right here. OK, we switched to ng demo. And then we cded /Angular. OK, so let's ls here. So this is actually the Angular repository. This is the code that Igor and I work on all the time. And it's a super big project, and it could take a long time to build. So I'm going to try Bazel build. And // ... is a way of saying, starting from the root, recursively build everything. That was the test of whether I typed the same thing that I said. You passed the test. OK, so this is going to take a long time. But that's partly because you can see it's loading stuff, so it's loading packages. And now it says the build has actually started, so it's figured out what it needs to do, or at least it's figured out some of what it needs to do. So you can see 32 out of 100 right now with 3 actions, 0 running, 4 actions. So the build is kind of warming up, like we've started to traverse this graph of all the dependencies we need to build. But this number of actions is always hovering around 4 or 5. That's because we're constrained by the number of cores we have on this machine for how much stuff we can do in parallel. So in this other window, which is a separate cloud VM, and I should point out these are really beefy cloud VMs with like 16 CPUs or something. Like I would expect the more actions to be running in parallel. Maybe it's 8 CPUs. So over here, let's see if I can type the same things. I'm going to add --config equals RBE. So this is just flipping a configuration bit in our Bazel settings that says that remote build execution should be available. So this one also has to read all of the build configuration and warm up. This would be faster, I think, if I hadn't just killed the Bazel server right before I started my talk. So let's see, how's the one on the left doing? Oh, it's up to 16 actions, 15 running. So yeah, it's a 16-core machine. That's as wide as the build can ever get over there. By the way, this demo is running with no caching. So we're building all of Angular from scratch. We're not getting any cache hits. So this is kind of the worst case of you change some dependency and now everything has to be rebuilt. Yeah. Thanks, Igor. I'm thinking you can all attend our internal talk where we explain Bazel to you. Bazel has a bunch of terms. You should not need to know these. The demo I'm showing you here has a lot of Bazel UI showing up just for illustration purposes. You won't ever see this stuff. Action is really just saying it spawns a process. And I'm going to let this run a little bit longer. I'm pretty sure the instructions said I was supposed to do one build ahead of time because this would be slow. But I don't care how long it takes to finish the thing. I just want to get to the point where, OK, so running over there went up to 26. And I'm going to see when we get to the point that the right-hand side is, OK, the right-hand side just beat the left-hand side. We've now run 1,000 processes. The left-hand side, which started way earlier, is only at 430. Yeah, see, we're compiling protocol buffers. Don't worry, that's not part of this either. This is what it looks like internally at Google. You won't have to compile everything from scratch like we're doing here. I did what it says. Oh, if I had done Bazel test, you would have seen something even more awesome happen. I'm going to let these run in the background a little bit. We'll come back to this later if we have time. OK, so I want to talk quickly about how do we hook up build tools? Like what is a build tool? Is Webpack a build tool? And how did we get to where we are today? If you came at this a couple years ago, you might have used Gulp. How many of you used Gulp at some point? Like, yeah, more than half. So Gulp was just one build tool, came after Grunt, and then other ones came after it. They seem to come and go. The idea with Gulp was that you would have to configure it to say, OK, for my Angular sources, you need to run ngc. For Sass, you might run Sass-C. For TypeScript, you might need to run TSC. So you configure it to run these different things, and then it goes into a bundler, and then that bundler produces JavaScript. So it looks a little bit like the picture I was drawing with Bazel in that there are separate steps, and you could imagine those things happening separately. So like Gulp was kind of an interesting model. It didn't work out very well. It seems to be falling off in popularity quite a bit. I think a couple reasons. It's too hard to configure it, although that's true with a lot of build tools. It wasn't incremental or parallelizable. You can express a graph of what things should happen to Gulp, but it will always do all of them, and like it's just sort of it can't use all the cores on your machine. It certainly doesn't parallelize over 100 machines in the cloud. The debugging was really hard, partly because it has this virtual file system layer. I don't know, you might have more reasons why Gulp didn't work out. But we completely changed the model after that, mostly because Webpack became super awesome. And so Webpack was really good at doing this one job, which was to take a bunch of JavaScript and turn it into one JavaScript file. JavaScript plus CSS, sort of bundling all your assets. But then when you wanted to use, let's say you changed the left-hand side there to TypeScript, then the bundler has to do the extra job of transpiling your TypeScript code. So that doesn't seem so bad necessarily. It does work pretty well for most users. Some downsides, though, the bundler now needs a plugin for each language. And there are other bundlers like Rollup. So now Rollup needs a TypeScript plugin, and Webpack needs a Sass plugin. And so for every combination of somebody wants to make a bundler and somebody has an input language, that whole matrix needs to be filled in. And of course, we have an army of open source volunteers who loves to be like, oh, I wrote the Node Sass Gulp plugin. And that is great that there's a lot of opportunities for people to contribute, but it also means that there's just this great diversity of software maintained by a whole bunch of different people. The bundler has and also it means if you wanted to start a new bundler, like you're expected to build every kind of input, so it makes it kind of harder to do. The bundler ends up becoming a build system, but these weren't designed to be build systems in the way Bazel was, so I would argue that they're not very good build systems. One reason is that there's a surprising interaction between the plugins. You add more plugins to your Webpack build, and they might interact with the plugins that you had before. There isn't a model to keep them separate, so it's kind of natural that they're going to have those kind of feature overlaps. What's the word I'm looking for? Feature interactions. It also means that it doesn't necessarily know how to run all of your tests. So now even though Webpack's your bundler and Jest is your testing tool, they both have to know how to transpile everything, and so you need more plugins for more things. We think that Bazel's plugin model is pretty cool. I should point out that like when I say plugin in Bazel, it's not like the plugins you have for other build tools where you can't really tell what it's doing. Everything Bazel does in execution, you could do with a shell script. So if you run Bazel with -- subcommands, it will just print out, I'm running this process, I'm running this process, like just the entire command line. We did a fun exercise earlier today of like dumping one of those command lines out for a node program so we could do some debugging. So in theory, you could just take your Bazel output and just like paste it all into a shell script, and you can reproduce the same build, except it's no longer incremental and has the other execution time properties that Bazel has. But basically, Bazel's plugins are just a way of running TSC or NGC. It's also cool because it means if the tool that you want to use has a command line interface, and that command line interface is documented, you're using that command line interface as the end user of the build tool, as opposed to most of the situation today where you're using a library to run the whatever tool, as opposed to using its command line interface. Keeps processes separate, so you don't have as much memory, as much possibility of memory leaks, and lots of other reasons it's good to keep things partitioned into separate processes, I think. Important to mention that Webpack is still great at its job, which should be code splitting and bundling. But it's just that we want the other tools to run independently. So we don't want it to be Webpack's job to understand how to run like the new version of the Angular compiler that we're going to talk about when you all ask us questions about IV. So that's cool. We've been experimenting with this for a while, but we are now asking ourselves the tough question, can Bazel work for everybody? And we want to figure that out this quarter. Actually, the reason Igor and I are in New York this week is to work with other Bazel rule authors to make sure that this can happen. If it can work for everyone, if we iron out all the issues, and I'll talk about what the issues are, then our plan is that the Angular CLI should start actually using Bazel. This would be eventually the default mode. If it can't work for everyone, then we probably don't want to keep doing it, because we don't want to end up with two different tool chains for us to support, and you go on Stack Overflow and somebody's answer is for the other tool chain, and like fragmenting the ecosystem doesn't help us or you. So that's our plan. So how do we figure out if Bazel can work for everybody? So one thing we did is we looked at performance, and I kind of copied this table from something that's still in progress, but it's pretty representative of what our thinking is on performance right now. So the left column is what you would get today with the Angular CLI. 2 minutes to run install. You don't have to do any configuration, so that's a 0. The initial build is 13 seconds, and so on. The important thing is that other than the second row of how to configure the thing, Bazel's best case, which is to say you take whatever Bazel's really good at, it happens to be Java, is the language that's supported the best. It meets or exceeds the time constraints that we have to match the current performance of Angular CLI. So that means the difference between, even though this looks kind of bad, this is good news, everyone. I tried to get Zoidberg, but it wasn't available with friendly licensing. So the good news here is that the difference between the second column and the third column is code that we should fix, but it's not that Bazel fundamentally can't do this job. So that's important. So we've ruled out that Bazel fundamentally can't hit the performance, except for the second row configuration effort. So like I said, the initial build speed, we want it to be on par. We can do things about that, like making the Bazel binary itself smaller, since it's going to be one of the transitive dependencies of the CLI if we do this. We think the target is 40 megs, which is still big, but we think we can save that much in other places. Maybe, still evaluating. We want the test round trip time to be on par, and so something we can do here is to keep Jasmine running between tests. Right now we shut down the Jasmine process under Bazel and start it again. It's just a question of how we host these tools under Bazel to take advantage of the features of how Bazel can do scheduling, like reusing a warm process instead of starting a new one. I mentioned configuration. The second row in that table was bad, so we need to auto-configure Bazel for simple projects, and we don't want any extra files to appear in your project. So essentially what this means is that there should be no migration for you. Assuming you are using Angular CLI and you're not tampering with the Webpack config or anything, we can change the behavior under the covers. All the documented CLI features would continue to work, and it should just be using Bazel instead of what it was doing before. Hopefully the only thing you notice is that it scales better. As we're designing this, we're making sure that you can just switch your Angular JSON file back to what it was before, and you can go back to the old build. So it's not destructive to switch in. So we think by doing those things, we could make this work. It's still a lot of work for us to do. Here's roughly what's coming up. So this thing is in Angular Labs. I don't know if you all have seen this. This is our logo for experimental. Angular Elements was originally in this experimental thing. Somehow it graduated. This means don't use it for production. This is something we're experimenting with. We don't support it the same way we support Angular stable packages. You certainly should go ahead and play with it if you're interested. If you're a big company, it might be worth getting a little bit of experience with this so that you have a plan for what to do when it's ready.